Okay, so for molecular compounds arise when you have two nonmetals bonding together. Molecular bonds, or covalent bonds, are much, much different and much, much stronger than ionic bonds are. Okay? Because in a covalent bond, electrons are not traded, they're shared. Okay? That means that the two parts of the molecule cannot be happy without each other. Okay? If we're putting that sociological spin on it like we did with the ionic ones. Okay? These two compounds, or these two elements, have to stay together in order to have their outer shells filled, because they're actually sharing the electron. They're not giving it away or taking it away from the other. Okay? So what we get in a compound like, let's say, water, okay, like you see on the left here, is you've got a hydrogen atom that has one electron. You've got another hydrogen atom here on the bottom that has one electron, and they're sharing those electrons with oxygen, which has 8 electrons. Okay, so if we're looking at oxygen, okay, and we look at it like we did the other day, okay, it's got 2 electrons in its lower shell, okay, and it's got 6 in its outer shell. So 1 and 2, 1 and 2, 1, 2. Okay, so it needs 2 more to fill that outer shell, which is why it gets along with hydrogen so well. Hydrogen comes along and it shares one of its electrons with oxygen. Okay, now hydrogen's outer shell is full with 2, okay, and oxygen's outer shell is now full with 8. They're both happy because now their outer shells are full. But they have to stay together because they're not giving those electrons away. They're sharing them in order to fill their outer shell. That's different. Okay, that's different than an ionic bond where they just give them away or take them. Okay, so these are going to have much different properties than ionic compounds. We said ionic compounds, you put them in water, they dissolve and they separate into charged particles, and that solution then would conduct electricity. The opposite is true for these. Okay? If I put this in water, they're not usually as soluble, so they're less likely to dissolve, period. But if they do, they don't break up. Okay? They don't turn into charged particles. Okay? So if I had distilled water and I added sugar to it, I'd get the sugar to dissolve, but the solution would not conduct electricity because there'd be no charged particles floating around. Sugar is molecular. Okay? It doesn't split. Okay? If I do that with salt, then I'm going to have a solution that will conduct electricity because salt will split into positively charged sodium ions and negatively charged chlorine ions, and electricity can flow between them. Okay? Everybody all right with that? Okay. Now, when we're naming molecular compounds, we name them in the order they're written. All right? We name the first nonmetal without changing its name. We change the second nonmetal's ending to I, same as we did with with ionic compounds. Sorry. Okay? But the difference is now, because the electrons aren't being traded, there's no fixed ratio for the two things to go together. Okay? Before with like, let's say calcium and chlorine, okay? Because calcium's a 2+ and chlorine's a 1-, there's only one way for calcium and chlorine to go together and have the charge balance. Well, in molecular compounds, we're not balancing the charges. We're sharing them. Okay? So there is no charge to be balanced here at all. So there's really no limit to the number of combinations in which oxygen and phosphorus could go together. Could have, like, they could be anything. All right? So I can't just go phosphorus oxide, because there could be a whole bunch of compounds with that name. That's why we use the prefixes for molecular compounds. All right, so we use di and tri and all that kind of stuff. Everybody with me on that? Okay, so just to give you all of those prefixes, you'll probably want to write these down because they're not in your notes. The prefix for 1 is mono, for 2 is di, for 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta. If you took anything in French or had a science teacher who taught French, they might have told you septa. Let me warn you, the chemistry department here hates that. Don't use septa, use hepta. It's like a trigger for Mr. Real. You don't want to trigger you. You wouldn't like him triggered. Okay? All right, number 8 is octa. Okay, 9 is nona, and 10 is deca, and we won't need to go past that for our purposes. Now, those prefixes are something that you will have to memorize at some point. Okay, you're going to need to know them off the top of your head, okay, by the time the unit exam comes around, because you won't be given a chart or anything that has those. Okay, we simply expect that you know what the prefixes are. Okay, luckily, they're the same as in geometry. Okay, 8-sided figure is an octagon, heptagon, hexagon, pentagon. Okay, just it goes like the shapes. All right, so if I'm naming molecular compounds, let's say I've got this compound here. Okay, and I want to name that. Right? What does N stand for? Nitrogen. Okay, how many are there? There's 2. So I'm going to say this is first off dinitrogen. Okay, and what's O stand for? Oxygen, and what's the prefix for 1? Mono. Now, if the element starts with a vowel, you don't have to go monooxide. You can just go monoxide. Okay, you don't have to put in the full thing. All right, so we write the first element, write its name normally. We don't change its ending. The second element gets its ending changed to I. That's true for all kinds of compounds, ionic and molecular. Okay, but we don't do it to the first one. Okay. Here's another thing that we don't do for the first one. If I have this compound here, okay, what does C stand for? Carbon. Okay. There's only one carbon. I don't put mono on the first element ever. Okay? I don't know why that is. It seems like a silly rule. I mean, if you're going to have a prefix for 1, you should use it all the time. But chemists have to feel important, so they got to be difficult. Okay? And they got to have silly little rules for everybody to remember. That's one of the silly little rules. You never put mono on the first element. All the other prefixes go on the first element, but not mono. Don't ask me why. Okay? All right, and then what's this stuff? Hydrogen. Okay, how many are there? 4. Okay, isn't hydrogen a metal? It can be both, right? And this time it's acting as a non-metal because it's listed second. Okay, it's another one of those little things that we have to remember. Okay, hydrogen's a metal if it's listed first. Okay. All right, is that sort of making sense? Molecular ones are pretty easy. As long as you remember the prefixes, you're pretty good on those. All right, so let's have you try the first 4 here. So for number 1, we've got nitrogen and iodine. Okay, there's only one nitrogen, so it doesn't need a prefix because it's the first one. Okay, and we've got 3 iodines, so this is going to be nitrogen, triiodine. And I suppose technically, if you were in English class, that should have a hyphen. I'm not an English teacher. I'll know what you mean. All right. Question number 2, okay, we've got carbon and we've got iodine. There's only one carbon, so again, we don't need a prefix on it, okay, but we're going to need what prefix on the iodine? Tetra. Again, that's probably one that should have a hyphen. Okay. All right, number 3, I've got nitrogen, and there's 2 of them, so what prefix do I need there? Dinitrogen. And what prefix on the oxygen? tri. And it has to end in "ide," so dinitrogen trioxide. Okay? A very common mistake that I see in molecular compound naming is people forgetting to end the second one in "ide," and they write something like trinitrogen or dinitrogen trioxygen. Okay? It's a compound, it's got to end in "ide" or "ate" or "ite," okay? Depending on what's in it. Okay, for number 4, we've got tellurium, and there's only one of it, so I don't need a prefix there. Okay, with astatine, and there's 2 of them, so that would be diastatide. Okay, questions on the first 4? All right. Try the rest of those. So for number 5, I've got phosphorus and sulfur. There's 2 phosphorus, so we're going to have diphosphorus. Okay, trisulfide. Okay, for number 6, okay, I've got 1 oxygen, so I don't need a prefix on that. So this is going to be oxygen, and then 1 sulfur, monosulfide. With me there. For number 7, I've got silicone, but I got 3 of them. So trisilicon, tetraphosphorus, or tetraphosphide, sorry. Okay, and for number 8, I've got 1 sulfur, so I don't need a prefix on it. Sulfur, and there's 2 chlorines, dichloride. Okay, and for number 9, silicon again, but this time there's only 1 of it, so I don't need a prefix. Silicon tetrahydride, and for number 10 here, I've got 4 borons, so tetra, boron, tricarbide. If you wrote carbonide, that's probably also fine, but typically we call it carbide. That compound probably doesn't even exist. Okay, I just started putting things together for the naming exercise. Okay. All right, questions on any of those? All right, now here's the thing. Every time we've done a naming exercise like this thus far, you've known exactly what kind of compound you're dealing with, and that's good to start. But you've got to be able to identify, is it ionic or molecular, and apply the right naming rules without being told these are all ionic or these are all molecular, or some of these need Roman numerals, or some of these have polyatomic ions. You got to be able to do that on the fly. That's the challenge, okay, is being able to do that, because when we get to reactions, this has got to be second nature. Okay, if we're writing out a reaction, we don't want to be stumbling over names at that point. Okay, we've got to just be able to do the names, no problem. And we're going to have a mix of ionic compounds, molecular compounds, polyatomic ions, things that need Roman numerals. All right, so you got a list there. Some of these are ionic, some of them are molecular, some of them need Roman numerals. No, I take that back. None of those need Roman numerals, but some of them have obviously polyatomic ions in them. Okay, there aren't any in there that need Roman numerals. Okay, so whenever you write the name of a compound, step 1, identify whether it's ionic or molecular. How can you tell the difference? Right, if it's got a metal in it, it's ionic. If the first thing is a metal, it's ionic. Okay, once you've identified, then you can apply the right naming rules. If it's ionic, you just name the metal, then the non-metal. Okay, if it's molecular, you name them, but you put the prefixes in. Okay, I'll give you a few minutes on those and see how we do there. And then we'll look at going the other way. I give you the name, you write the formula. Okay, 'cause so far we've only really done the formula to name. Okay, let's just quickly look at the first 3 and then we'll pack up and get the desk wiped down here. All right, so for number 1 here, I've got lithium and chlorine, ionic or molecular? It's ionic. Lithium is a metal, okay, so I name this like an ionic compound. Lithium and then chloride. Right, don't have to do anything else. Don't need prefixes, okay, there's no Roman numerals for that one because lithium doesn't have more than 1 charge. Okay, number 2, I've got chromium and fluorine. Okay, what's the charge on, sorry, chromium doesn't need a Roman numeral, does it? It does. It can be a 2 or a 3, doesn't it? Okay, so that one does need a Roman numeral. I lied. Okay, chromium fluoride. Okay, I need to figure out which Roman numeral that is. Fluorine is always a -1. There's 3 of them, so that's 3 negative charges. Which Roman numeral does chromium get? Okay, it's got to be a +3 to balance those off. Okay, and then number 3 here, I've got phosphorus, non-metal, bromine, non-metal. So this is molecular, so this is going to be phosphorus. What prefix does bromine get? Tribromide. Okay, we'll continue on with that tomorrow after your quiz. I will post a practice quiz at some point today. Okay, so make sure you check it out tonight and give it a try. It will be very similar to the one you write tomorrow. Okay. All right, if everybody can get their desk cleaned off, I'll come around and spray them down, grab a paper towel, and we'll wipe them off.